We are factoring. It is very important that you know how to factor so that when we get to section 5, you actually know how to factor to solve something. So there are lots of different things that we can factor, so we're going to kind of go through each thing, each type, and then do a couple of practice problems. So the most basic type of factoring is just factoring out a greatest common factor, or GCF. So back in, I don't know, like when you did this, some grade, when you were little, you took just like basic numbers and you looked at the greatest common factor of the numbers. So you were looking at numbers that could go into like 2 or 3 or 4 or whatever. Numbers that could go into those numbers, or numbers that these guys can divide. So what is the biggest number that 24 and 30 can divide?
Oh, 6.
Yeah. So that would be their greatest common factor. So like both of them can divide 2 or 4 or 3, or actually it's bigger than 6.
Oh, really?
Yeah.
Oops. Oh,
No, it's not. I'm sorry. I was thinking of a different number.
8.
I was thinking of.
You're about to make me look stupid.
No, I was like 12. No, that's stupid. Yeah, so both of them could divide all of these numbers. Like 24 can divide 12, but 30 can't divide 12, so that can't be it. So it's the biggest one that both of those can divide. When we talk about numbers with letters combined, so like put an x here and an x squared here. So how would that change the greatest common factor? It wouldn't just be 6. What else? What variables?
6x.
Yeah, so 6x. Okay, so when we factor out a greatest common factor, it's kind of like the distributive property, but backwards of what you're used to. So for 6x cubed and 4x, both of those can divide a 2 and an x, right? So that would be the greatest common factor. We would factor that out. And then what would be left in some parentheses would be basically the quotient of these two terms and the 2x. So what's 6x cubed divided by 2x?
3x squared.
There you go. And then what's 4x divided by 2x plus 2?
Ms. Rep,
Yes.
do you need this chair or does it belong to somebody else?
I was trying to figure out whose it was. It's not mine, but it was in my room. So I just ran out of time. Okay, so if we were to distribute, so this is hypothetical, you don't want to do this because we're done, we factored it, but if you were to distribute, okay, you should get what you started off with. And if you don't, that means you factored out the greatest common factor wrong. Okay, so basically, in a nutshell, we're like dividing, and if we multiply, we should get the original thing. All right, so all we're doing is taking out a greatest common factor. Whenever you're factoring, you should always check this first, greatest common factor, okay? Whenever we're eventually going to solve, whenever we solve, you always want to take out a greatest common factor or divide by a greatest common factor, depending on the question, okay? Or things with 2 terms. So the first 2 are ways you can factor binomials. After this, we have trinomials. So this is a difference of squares. A difference of squares is what it sounds like. Difference means minus. Okay, and the other 2 things surrounding the minus sign are going to be perfect squares. Okay, to factor a difference of squares, you're going to have 2 binomials. One is going to be the sum of the square root of the 2 terms, and one is going to be the difference of the square root of the 2 terms. Okay, by doing this, if you were to multiply these 2 back out, you'd have a squared plus minus ab here, plus ab here, and then minus b squared. So you can see the 2 middle terms will cancel out, and you're left with just a squared minus b squared. So in order for the 2 middle terms to cancel out, one would have to be positive, and one would have to be negative. If they were both positive or both negative, they wouldn't cancel out, they would just double. So when you factor a difference of squares, you have to know what the square root of each term is. So what is the square root of 4x squared?
2x.
2x. And then what's the square root of 9? 3. And so when factored, this would be 2x plus 3 and 2x minus 3. If you want to check it, you would just multiply those out. So you would FOIL. Okay, and if you FOIL and you get 4x squared minus 9, then you're good. And if you don't, then bad. Try these. 16x to the 4th minus 1. So you got 16, we can square root that. We have x to the 4th, we can square root that too. So this would be 4x squared when square rooted, and then 1 can always be square rooted to 1. So if you were to factor 16x to the 4th minus 1, you would have one sum of 4x squared and 1, and then one difference of 4x squared and 1. So 4x squared plus 1, 4x squared minus 1. Now if you look, you can't really do anything with that because it's a sum. But this one, you could factor again because it's a difference of squares again. So you would want to keep going and factor completely because this one and this one can be square rooted, right? So what you would do is you'd leave this guy. Can't do anything with him. But this guy, you could factor again to 2x plus 1 and 2x minus 1. Okay, and that would be factored completely. So sometimes you can factor and factor again. Yes?
How come it's only with subtraction?
Because in order for us to not have that middle term, in order for it to just be a binomial, one of the terms has to be positive and one has to be negative. Because like when you take like for example 1 and negative 1, you put them together, you get 0. So there's no middle term. With addition, you know, so you would maybe guess this would be like 2x plus 1 and then 2x plus 1, right? The last two terms multiplied together would have to make a positive 1. Well, if both of these are positive, then you'd have a middle term of 4x. And if both were negative, you'd still have a middle term of negative 4x. So they're not canceling out.
Oh.
So the last two terms have to multiply to make this guy. In order to get a positive, they either both have to be positive or both have to be negative. But if both are positive and both are negative, the middle terms will still be there. And it'll look like a trinomial, not a binomial. So that's why it only works with minus, because with minus you can have one positive, one negative, and then they'll cancel. And you still got like the right number at the end. So there is no sum of squares, unless you use imaginary stuff, which we will do stuff with those. There are two different kinds of trinomials that we're going to focus on, and one is with a is equal to 1, and one is with a is not equal to 1. When I say a, I'm talking about quadratics in this form. Okay? So the leading coefficient, that's what this guy is called.
Let's go.
It's a leading coefficient because it is the coefficient of the x with the largest exponent. So he's leading because typically you write things in descending order. So you start with the biggest exponent and then work your way down. Right? You don't really factor with like these guys all mixed together. No, you don't do that. You always factor when
Makes
it's in
it
descending
complicated.
order.
Yeah.
Yeah, it's just harder to. You can do it, but. So when the leading coefficient is 1, that makes it easier to factor. When it's not 1, it makes it harder to factor. When the leading coefficient is 1, we can kind of like do this faster. We don't have to go through as many steps, okay? All you're looking for is two numbers that multiply to 21 and add to 10. Now, if you're not good at thinking about these numbers in your head, then what I'm going to ask you to do is off the side, you're going to make a list of all the numbers that multiply to 21. Now, there aren't many of them. Okay, that's a list of all that, well, and then you got the negative equivalents. These are all the numbers that you can use to make a product of positive 21. Okay, and it matters if it's positive or negative, so positive 21.
Yeah.
Now, which two of those add to positive 10? 3 and 7.
Do they now?
So that means to factor, we would have x plus 3, because positive 3, and x plus 7, because positive 7. And that would be that.
Wait a second. Can I copy that down real quick?
No, I'm going to erase it right now. That you can factor out a greatest common factor first, and then factor the trinomial after that. Now, like I said before, whenever you start factoring something, you should always check to see, is there a greatest common factor that we can take out? So we haven't really been doing that but that's the first thing you should check. Can I take something out? Is there something that all these numbers divide?
3.
Yeah,
3. So what you're gonna do, actually in this case, it would be even more helpful to take out a -3. In general, if that leading coefficient is negative, go ahead and take out a negative, because it's really hard to factor when the leading coefficient is negative. So we're gonna take out a -3. Okay, what's left?
Wait, what's left? Oh, x squared plus 2x plus 40.
There you go. Now, sometimes we can factor again, right?
Yeah.
So after you take out the -3, sometimes you can factor the trinomial that's left. So is there a number, or not a number, are there numbers that multiply to 40 and
Nope.
and add to 2?
Nope.
You sure?
Yeah, you know why?
Can I make something negative? And that'll
Oh,
work.
yeah, maybe no.
It has to be a +40, so that means all of
No.
these and all their negatives.
Doesn't work.
Doesn't work.
I think yeah.
Okay, so it's not gonna work. So
It
that
gets
means that
close.
this is it.
Oh. Aw.
Alright. Try that you try, it might be different. Does it matter what order you put the factors in?
No, because it's
It's supposed to
foiled.
be the same.
Or no, it's not foiled. It's it's factored, so it's like it's already in these.
Okay.
It should be the same thing.
So it's
even
fine.
if you move it in.
What's
like-
the property called?
It's called distributed.
PEMDAS.
No, no, it's
What?
Please excuse
There's
my
property that
ignorance.
says it doesn't matter what order you multiply things in. Commutative. Commutative property of
Commutative.
multiplication.
Oh,
I said
from
So,
last one.
if you had switched any of these,
what's
it would be the same thing, however, comma. We typically put the greatest common factor first, because
Oh, that makes
otherwise
sense.
it's just like awkward a little bit, but it doesn't matter. Like in theory, we just typically write it first because it's like usually the shorter one. It just looks prettier.
I know, I look
But it doesn't matter, okay? Alright, so take out the greatest common factor and then look at your trinomial and see if it can factor again or if it can factor again. Alright, now, additional examples.
Oh, I love these. These are my favorite part of the day. I love additional examples. That was really neat.
Was it?
Oh God. How much energy do you have today?
Peanuts.
This is the peanuts. Sometimes things can look quadratic and can be factored like quadratic things. Okay, wait. Sometimes things don't look quadratic but can be factored like quadratic things because
So-
they're in quadratic form.
So does that mean you can use the quadratic formula?
You can, so here's the thing. When you factor, for the sake of factoring, you can't use a quadratic formula because the quadratic formula is something you use to
Oh,
solve.
solving.
Yeah,
Yeah.
we're not solving yet, but we will.
Okay.
Anything that can be factored to solve can be solved using the quadratic formula, but usually it's faster.
Yeah, I
to
feel like
factor.
the quadratic formula is
Takes
like the
forever.
universal solving unit.
Yeah. Well, but it's only for quadratic things or
Well,
things
yeah.
in quadratic form. So this is an example of something that's in quadratic form, okay, but isn't necessarily, doesn't look like it is. So the reason it's in quadratic form is because I could rewrite this like this. Something squared plus or minus that something, and then a constant. Okay, so anything that can be written in the form this is of quadratic form. So that means basically whatever's in the middle, if you can square it to get the first thing, then it's in quadratic form. Okay, so x squared is x to the 4th. So to remind you about like exponent rules, you would multiply these, and that would simplify to x to the 4th. So if you look, I picked the same example as like this guy right here to show you how they're gonna factor to similar things. So let's pretend we don't have this, okay? This factored to x minus 2, x plus 1, right? This is gonna factor similarly. However, so you have your minus 2, you have your plus 1. Instead of putting an x here and an x here, we're gonna put x squared here and x squared here. So that's the difference. Whatever that middle term is, that's what you put here, right? So our middle term was x, that's what we put here. So that when we multiply them together, we get x squared, right? Because remember, the opposite of what we're doing would be foiling. So after we factor, if we wanted to check, all we would have to do is FOIL these out.
For the lead.
So let me show you how that works. If we were to FOIL these out, we would do x squared times x squared times 1, negative 2 times x squared, and negative 2 times 1. And when we simplify, you see how we get the original?
So FOIL is first, opposite, or
First, outside,
inside, and last.
Last, yeah.
Alright, can I try that real quick? First, outside, inside, last. Outside, inside.
Okay, so again, things can be written in quadratic form. You might not be able to notice it. In this chapter, it'll be easy to recognize because it's like the quadratic chapter. Moving forward, anytime you see a trinomial and you're trying to solve it, just think I could probably factor this because there's only so many ways you can solve. So I'm going to make it a new example for you for the U-try. Is that not recording the whole time?
Inside of the thing instead of the outside.
Can-
I did x squared to the third power.
Oh, no, yeah. So the middle term is the thing that when squared should give you the first term. So x cubed, when that is squared, is x to the 6th. So that means this is in quadratic form and we
Can you
can
get, like,
factor.
Ugly numbers.
Define ugly numbers. You mean ugly exponents or ugly numbers? Oh, you mean like decimals?
Exponents.
Sure.
It'll be like a.
Do like x to the 2.4 plus 3x 1.2
Oh, God.
minus 18.
Mr. Harvey, you know you have a.
We haven't done rational exponents yet, so I won't give it to you, but yes.
Not bad.
You could also do like square roots. So something like x to this, or just x plus 3 root x minus 18, because the square root of x squared is x. So it's like another thing that's in quadratic form. Anyhow, so for this one, you would factor, what are two things that multiply to negative 18 and add to 3?
6.
6 and negative 3.
Well, so it'd just be 3 and 3
So
because.
positive 6 and
Yeah.
negative 3 would be your two numbers. And then in front here, we would put x cubed and x cubed. And then if you wanted to check, when you FOIL, you should get this guy. So when you multiply these two, you get x to the 6th. Here's negative 3x, positive 6, that's going to make this guy. And then at the end, we have negative 18. All right, trinomials where a is not equal to 1. Okay, and then after this, we're going to do a couple more. So again, like save room. We have difference and sum of cubes after this. And then we also can have like 4 terms. All right, so trinomials where a is not 1. So here, you can just always use like the guess and check method. So the guess and check method is just throw some stuff in parentheses and then kind of FOIL in your head and see if it works, okay? Now, some people are really good at that. Some people, it takes a while. So if you're really good at that, go ahead and do it. There are a bunch of different techniques for factoring these. I'm going to show you one technique. The reason I show you this technique is because it makes sense mathematically. It's not just like some random step, like set of steps that happens to work. So this technique is called factoring by grouping. So if you wanted to like watch more of it. Okay. So to factor by grouping, we have to make groups of things. And then what we do is we're creating 2 groups of 2 binomials, and then we factor using greatest common factor technique. So the very first thing that we did. So what I like to do is I take A and C, okay? Multiply those together. So A is 3, C is negative 10. When you multiply those together, you get negative 30. Okay. Then you are going to see what numbers make negative 30. So I have like 1 and negative 30. I have negative 1 and 30. I have 2 and negative 15. I have negative 2 and 15. 3 and negative 10. Negative 3 and 10. 5 and negative 6. -5, and 6. Now I can come up with a pretty quick list by going in order. So if you look at like my first number, I start with 1, then 2, then 3, skipped 4 because there isn't one, 5, 6, 7, 8, 9, 10. Okay, you can like go up the line, but obviously once I hit 5, then I go to 6 and it's the same thing, and then there's no 7, there's no 8, and then I'm at 10 and I already listed that. So if you go in order, it's easier to list. If you just kind of randomly start thinking of things, you're gonna forget one. So go through your head and go, oh, does 1 times anything? Yeah, obviously. 2 times anything? 3 times anything? Go in order so you don't forget one, because usually the one that you forget is the one that the answer is.
Yeah.
Now, after making that list, you are going to look and see if any 2 of those, I think there's a typo in this one. Yeah, okay, wait. So there's a typo on this, so we're gonna fix it by doing this. So make your 10 positive.
Oh, that's
Yeah. And then I'm gonna, so this is a positive 30.
Wait,
What?
Miss Rep, can't we do -15 and negatives?
Oh, it wasn't a typo, just kidding.
Hey,
Sorry.
I'm using
I
pen
think
here.
there is a typo on here though, because I feel like I remember one from last year being a typo. And
What if you
I don't-
remember
And
the
I don't
exact
remember,
problem?
I don't know, remember if I fixed it. Maybe it was that one. I don't know, maybe not.
We'll figure it out.
Yeah, no, you're right. Okay, so street that. So then you're gonna look for 2 that add. So of that list, you're looking for 2 that add to positive 13, and like she said, we can actually pick positive 15 and negative 2 will add to 13. Okay. So you're picking the 2 that add to the middle term. So you multiply the outside terms, make a list, pick 2 that add to the middle term. Then what you're doing is you are rewriting this as a, this isn't a number, or this isn't a word, but a quadnomial. So a polynomial with 4 terms. So you're taking a trinomial and you're turning it into a quadnomial, not a word. But I'm gonna make it a word.
It's an idea though.
So you keep the first.
That's how words are made.
Mm-hmm.
That's how words are made. You keep the first and the last term, okay? In the middle, you are going to rewrite this guy as those 2 guys instead. So -2x and 15x. So you're splitting up 13x into 2 linear terms instead of 1. The purpose of this is to factor by grouping. So by creating 4 terms, we are grouping this into 2 binomials that are easily factorable by taking out a greatest common factor. So usually what I do is I go like this in my head. I draw a dotted line down the middle in my imagination. And you're focusing on each half one at a time. So just looking at this half, what is the greatest common factor, or what is something that these 2 terms can divide? 1x.
Okay, what,
So that is going to be what you take out of those 2 terms, is an x. Then you'll have a binomial left over, 3x minus 2. Okay, so you factored basically the left half.
So that's just like, okay, take out an x on each side and then it's boom. But if
Then
it
you're
was-
going to move to the right half completely unrelated to it. What is a number or a number and a letter that you can take out of the second
5.
half?
5, yeah.
5. Okay, so is it a positive 5 or a negative 5?
Negative 5.
Positive 5. So plus 5.
Why not a negative?
I mean, you can take out a negative 5, but it's not going to work.
Oh.
Here's the thing. If this is positive, take out a positive. If this is negative, take out a negative.
Sure.
Got it? Okay. All right, so if we take out a positive 5 out of 15x, you're left with 3x. If we take a 5 out of 10, you get 2. Now, do you see how this binomial and this binomial are the same binomial? That's good. If they're not the same binomial, you did it wrong. Or it's not factorable and you tried to factor it and it's like, actually, you shouldn't have been able to do that at all. So these 2 have to be the same in order for this to make sense. Basically what we have here is like an excessive distributive property laid out. I'm going to erase my little dotted line now. Instead of writing x plus these guys, and then 5 plus these guys, I can just write x plus 5 and 3x minus 2. If you think about foiling, you take x and you multiply by these two, right? And then you take 5 and you multiply by these two, right? It's first, outside,
Inside last.
inside, last. That's what we have here. Instead of writing this, we can write it smaller. And when we write it smaller, we have created 2 factors. So basically what you're doing is, whatever's on the outside becomes 1 factor. Whatever's on the inside becomes 1 factor, and you have your 2 factors. Now, sometimes what's left you could factor again. Sometimes it's like you keep going. In this case, we're done. So just to recap, so you take A and C, you multiply them together, you make a list. Sometimes you don't have to make a list. Sometimes it's obvious. Sometimes if the number is small, you don't have to make a list. You can just think of it right away. As you continue to do examples of this, you just might get better at it. You might not need to make a list. I'm going to make a list so you can see where I'm not just whipping these numbers out of nowhere. Of your list, you're going to pick the 2 numbers that that add to the middle term. You're going to split the middle term up into those numbers. Then, and so you might see this. Sometimes you'll see, like if you've ever do this with Mr. Johnson, he'll group this and this before doing the next step. So that basically you're factoring this group, and then you're factoring this group, and then you add in between. So sometimes you'll see that. And then whatever's outside becomes 1 factor, whatever is inside becomes another factor, again, because of basically the distributive property. We're just using it backwards. So all factoring is basically the distributive property backwards, but like obviously more complicated.
So is that the final answer?
So that would be our final answer. If for whatever reason, when we finished, we had like a difference of squares here, or maybe we could have taken out a greatest common factor, then maybe we would do that. So like if this guy was like 2x plus 10, then maybe we would like take out a 2 or something to get that. So sometimes you get that. Not in this case. Okay.
Try the U-try.
Same technique, except for these, there's something that we can factor out first before we go. If you don't take out a greatest common factor first, you can still factor it using that technique. It's just that at the end, well, number one, it'll be harder because your numbers will be bigger, and at the end, you'll be missing one of the factors because he'll be like hiding in there. So you can take him out at the end, but like I said, it's easier just to take it out at the beginning so you don't forget, and also so your numbers are smaller. So if you look, all 3 of these terms are divisible by 2. So we'd want to take out a 2 before we start. Sometimes that's all you can do. So sometimes you'll go through this whole process and you won't actually be able to do anything. And then you'll be like, oh, it doesn't factor. Well, like, it doesn't really factor, but you can always take out a 2. So, okay, so now I'm going to take my 2 and my 7. I'm going to multiply them together. I get 14. So that's 1 and 14, negative 1 and negative 14, 2 and 7, negative 2 and negative 7, and that's it. Of those 4, are there 2 that add to 9x?
2 and 7.
2 and 7. Okay, so here's how you're going to write this. You keep the 2. Okay. You have 2x squared plus 2x plus 7x plus 7. Don't lose the original greatest common factor, okay? Because it's part of the question. If you lose him, then you're forgetting that, you know, that was part of the original trinomial. So you don't want to do that. All right, and then again, keep the 2. I'm going to use brackets. So I have 2 groups, 2x squared plus 2x, and then I have 7x plus 7, like that. I'm going to take out the greatest common factor out of each group. Again, not forgetting that I have a 2 from the beginning. So the greatest common factor of 2x squared and 2x is what?
The
2x, yeah.
yeah.
Then we're left with just x plus 1. Because it's like everything goes away. 2x and 2x, you got 1. Alright, and then here we're going to take out what? Out of 7x plus 7?
7.
Yeah, 7. And again, we're left with x plus 1. Alright, now your final answer. You have your 2 from the beginning. You have the greatest common factors that you pulled out on the outside, 2x and 7. And then you have the insides, which are x plus 1. So you have 1, 2, 3 factors, but one of your factors is just a constant.
Yay.
X cubed is x cubed. Now, what thing cubed is 8?
Wow.
So
It's
confusing.
2. It's 2.
Okay.
So, x cubed minus 8 can be written as x cubed minus 2. Wait, why did I put a square there? Cubed. Okay. So, x cubed minus 8 can be written as the difference of 2 other things that are cubed. Those things that is cubed when you get these things. Those are like the a and b, so that's kind of what I was giving you over here. So which one are we using, the sum of cubes or the difference of cubes?
Difference.
We are using a difference of cubes because there's a minus sign involved. Now, our a is x. Our b is 2. So all we're going to do is basically substitute in x's and 2's into this guy. It's not a formula, okay, but if you want to call it a formula, you can. It's a technique for factoring. Now, since you've never seen it before, and you're just plugging stuff in blindly, it is kind of a formula to you. So, the first piece of a factored out difference of cubes is a binomial. So you start with a binomial. So you just take basically the cube root of the first term and the cube root of the second term, and you're going to find the difference of those. So the difference goes first. Okay, so if it's a difference of cubes, you're going to start with a difference of a binomial. After the binomial, you will have a trinomial. In that trinomial, you will have only sums, like plus signs everywhere. The first term in the trinomial is going to be your a squared. So our a is x. So we're going to have x squared. Then we will add our a and our b multiplied together. So the product of a and b. That's just going to be 2x. I'm not going to write x2, that's awkward. Then we will add our b squared. So our b is 2. So what is 2 squared? 4. So we have a binomial and a trinomial. The binomial is minus, the trinomial is only pluses. There's this thing, it's soap. I don't know, I just think it's a little weird. It's something to help you remind you of the signs. It's called SOAP because same, opposite, and then always positive. So, like, for example, these two are the same, opposite, and then the last one's always positive. Same, opposite, always positive. I don't know if it's helpful for you. I don't think it's helpful. I think it's weird.
Yeah.
But, like, that's just my personal opinion, so I'm giving it to you. SOAP, it's a method for remembering the signs that go in the cubic thing.
I feel like acronyms in general just.
I think acronyms are dumb, yeah. I don't like
No,
them.
SOHCAHTOA really helped.
Oh,
Okay,
no,
true.
no,
SOHCAHTOA
that's the only one
does.
that-
SOHCAHTOA does really help. You're right. You're right. All right. So anywho,
In Penn
after
Boston, I was
you
younger.
factor,
The one with like Samawakati, Mananalawahi, like.
after you factor, you may think, oh look, a trinomial. Maybe I can factor that. You probably won't be able to. Okay. If you want to get creative and use imaginary, just don't. Just leave it. The whole reason we have to factor using this technique is because it's not just as simple as like, oh yeah, we're gonna get like stuff and it's gonna factor nicely. We're gonna get like 3 binomials. No, you're not. You're not gonna get 3 binomials. So you're not gonna be able to factor this guy. There are cubics that do factor to 3 binomials. We won't do those until I think it's chapter 5, so like next chapter. So once you like do this, you're basically done. We will probably keep going and we'll solve these, but you won't. Like you're done. So after you factor, you're done. In the next chapter or the next section, you'll like factor, you'll set it equals 0, you'll solve. So you'll solve, but that's pretty much it. Okay. I was gonna say like that's not right. So try this, you try.